Hello, this video is for IXL, Activity A1.K.3. It is titled Identify Solutions to Inequalities. And the 3-character code for this activity is 5 uniform echo. So we're supposed to identify the solutions to these inequalities that we have here. Remember, inequalities are statements that use these little arrow looking symbols: less than, greater than, less than or equal to, greater than or equal to, or possibly not equal to, which is an equal sign with an arrow through it. So what do we mean by a solution to an inequality? Well, a solution to an inequality by definition is any value that when that value is substituted in for the variable, it creates a true statement, then that is said to be a solution to the inequality. Now remember, there can be many numbers that are a solution to an inequality, and so we're just going to check out the ones that they give us. So with that said, let's go ahead and move along. Look at the first question. It says, is g equals -7 a solution to the inequality below? So we have -12 is less than g. So what we need to do is we need to substitute in the -7 for g. So let's do -12 less than and -7. Well, think about it. On a number line, if we have these 2 points here, where's -7? We'll put it there, and we know that -12 is over here. So -12 is to the left of -7 on the number line, so -12 indeed is less than -7. So this is a true statement. Therefore, -7 is a solution to the inequality. -12 is less than g. On the next one, c equals 10. Is this a solution to the inequality below? The inequality that we have is 8 is less than 10 divided by c. So let's go ahead and plug that in. And we would have 10 over, and for c, we're going to substitute 10. So put 10 in there. Now let's go ahead and simplify that 10 over 10. Well, any number over itself is equal to 1, right? Now, is 8 less than 1? Indeed, it's not. 8 is actually greater than 1. So this is a false statement. Therefore, the answer is no, this is not a solution to the inequality. Or no, 10 is not a solution to the inequality. 8 is less than 10 over c. On the next one, which of the following are solutions to the inequality below? And select all that apply. So which one of these are less than 11? So if we go ahead and think about it, I always kind of like to, whenever you have a bunch of numbers, instead of looking through them, and I don't always write this out, I just actually kind of picture it in my head, right? So I'm going to go ahead and plot that 11. And it's talking about less than, that anything that is h has to be less than. So we're talking about everything to the left of 11 on the number line. So let's start considering which one of these four, or how many, it could be all of them, right, are actually less than 11. 6, well, 6 would be somewhere to the left of that. So this one checks out. That's a true answer. 4 is less than 11. That one also works out. What about 7? 7 also is to the left of 11 on the number line, so it's less than 11. And 3, well, 3 is also to the left of 11 on the number line, so that is correct as well. It turns out to be that all 4 of these answers are correct. On the next one, let's go ahead and, you don't have to draw the number line, but just kind of picture it in your head. Let's go ahead and plot that -6, and we're talking about anything greater than or equal to -6. So I'm going to put my -6 down here. And at this point, all right, -6 is greater than y. Oh, here's the tricky part about it. Let me back up for just a second before I get crazy in this. Notice that the variable is on the left side of the inequality. And I've talked about this in other videos, that if we put the variable on the left side and the number value on the right side, and if we're going to switch the variable from one side to the other, then we have to also switch the sign. And one way to think of that is, look, it's pointing at the y. Let's keep it pointing at the y. So let's go ahead and do that. So now we see that we're talking about where y, any value of y that is less than or equal to -6. So whenever we think of it that way, maybe I should put my -6 over here. So you can see how switching the variable to the left side and always keeping your variables to the left side can kind of help you keep that which way the arrow is or which way on the number line it is. And it's a little bit easier to keep track of. So with that said, let's go ahead and think about each of these. What about -1? Well, on a number line, -1 would actually be over this place, someplace, right? -1 would be to the right of -6. So this is not a solution. That would create a false statement. What about -11? Well, -11 would be all right. That would be down here someplace, right? -11, and it indeed is less than -6. So this is a correct answer. Oh, and notice another thing about IXL. This previous question up here, it said select all that apply. So there could be more than one answer. However, this one here says, which of the following is a solution of the inequality below? So it kind of implies a single, like just one answer, just one correct answer. But we'll go ahead and we'll double check. Just want to point it out that whenever they say select the correct one, usually there's just one answer. If they say select the correct, select all that apply, then you may have more than one correct answer. It's still a good idea to go ahead and check each and every possible selection. So let's continue doing that. -5, well, -5 is going to be like here someplace, right? So that's actually going to be greater than -6, and we're looking for y is less than or equal to -6, so this one doesn't work out either. And then -2, well, that would be like right about here on the number line. So it's to the right of 6, so it's actually greater than 6, not less than. So this one is incorrect as well. Turns out to be that y equals -11 is the only correct selection of the 4 that they've given us. On the next one here, I put down here evaluate or solve. Now, whenever I created this presentation, put it together, I was thinking about just solving them, because whenever I do something like this, since I already know how to solve the equation, get it down to where I just have a variable on one side, the inequality symbol, and then a value on the other side, just like doing equations, normally I would do that. And then I just look for the ones that are selection possible choices that I have, right? However, since in the following lessons later on, we're going to talk about solving inequalities, here I'm just going to evaluate them. So I'm just going to evaluate each possible answer instead of solving and looking at it that way. So let's go ahead and just evaluate. Evaluate means to substitute the value in, do the math, and get it down to where you can just compare a couple numbers, right? So let's do this one here. -7 less than, and the value of g is -4 minus 1. Well, I like to think of a subtraction of a positive is plus a negative, so I'm going to change that to addition and then put the negative sign in front of the 1. If you're not sure what I just did there, check out the lessons about adding and subtracting integers. So I'm going to take my -7 less than -4 plus -1 is -5. Is -7 less than -5? Indeed it is. -7 is to the left of -5 on a number line, so this one checks out. Again, it says select all that apply, so I'm going to check all of these. Next one I have -7 equals, let's substitute for g -5 and -1. Again, I'm like plus a negative instead, so I'm going to change that to addition and then change the sign on the following value, which is 1. So +1 becomes -1. There you go, a little mini lesson on adding and subtracting integers. So -5 plus -1 is -6, and I just realized I made a major mistake. I am so used to doing equations that I am using an equal sign. We should be using a less than sign. So there we go, less than. -5 plus -1 is -6. Is -7 less than -6? Indeed, -7 is to the left of -6 on the number line, so that one is true as well. Here we have -7 less than, and what's the value of g? -10. We're going to subtract 1, which is actually plus a -1. So I end up with -7 is less than, and then -10 plus -1 is -11. -7 is less than -11. No, that is not true. -7 is actually greater than -11. So this is not a correct choice. And finally, -7 less than -3. Again, just substituting that value of g here, and then put in the -1, which is plus a -1. Now I have -7 less than -4. Is -7 less than -4? Indeed it is. So g equals -3 is a correct solution also. Or it's a correct choice because -3 is a solution. There we go. On this one here, let's go ahead and take our 15 is less than, and then d is going to be 36/9. and then add 4. So let's simplify that 36 over 9. 36 divided by 9 is 4. Bring down our plus 4. And then we have 15 less than 8. Is this true? No, 15 is actually greater than 8. So 36 doesn't work. On the next one, 15 less than 54 over 9. Again, I'm just substituting in the value of 54 wherever I see the value of D. Well, for this one, we'll substitute different numbers for the other ones. And then add that plus 4. Now let's go ahead and do 15 less than 54 divided by 9 is 6. Let's add 4 to that. We end up with 15 is less than 10. True statement? Nope, this is not a true statement. So I'm going to go ahead and rule this one out as well. On the next one, we have 15 less than 144 over 9, and then add 4. Well, 15 less than, and 144 divided by 9. Well, I know that 10 9s will get me to 90, and that would leave me another 54, and then that would be another 6 9s. So that should be 16, right? Then bring down my plus 4. So I have 15 less than 20. Indeed, this is a true statement, so that is correct. And then finally, on the last one, 15 is less than 90 divided by 9. And what if I add 4 to that? I would end up with the 15 is less than 90 divided by 9 is 10. Let's add 4. And then we would end up with 15 is less than 14. Is this true? No, it's not. So the only correct solution would be the third one, where D is equal to 144. On this one here, we're saying, what if we took 11, multiplied it times the value of B, then added 2, and it should be less than 51. So let's evaluate each of these. Let's do 11 times, and then I'm going to put the parentheses. Wherever I see the variable, I'm going to put a parentheses. A really good practice to kind of help you keep things squared away. So in this case, B is 5, so I'm going to put a 5 in there in place of that variable B. Plus 2 is less than 51. Now 11 times 5 is 55. Let's bring down our plus 2, less than 51. And now 55 plus 2 is 57, less than 51. Is this a true statement? No, it is not. 57 is actually greater than 51. Here we have 11 times 12. We're going to substitute in 12 for B. We're going to add 2 and see if it is less than 51. So 11 times 12, well, let me see. I think that's 131 if I'm correct. If I had 10 11s, that'd be 120. Yep, it's 131. 131 plus 2 is less than 51. And then 131 plus 2 is going to be 133. Is this less than 51? No, this is not a true statement. So B equals 12 is not a solution. On the next one, we have 11 times, and what is in the value of B is 1. So we're going to put that in place of the value of B here. In this inequality, we'll add 2 and see if this is less than 51. I think this one's going to work out. We end up 11 plus 2. Is this less than 51? Well, 11 plus 2 is 13. And is that less than 51? Indeed, that is. That checks out. So B equals 1 is a solution. And next we have 11 times 7. And then we're going to add 2. Is this less than 51? 11 times 7 is 77. Let's add 2. And then 77 plus 2 is 79. Is 79 less than 51? No, 79 is greater than 51, so this is incorrect. The only correct choice is the third one, B equals 1. And notice it says, which of the following is a solution to the inequality below? So this kind of implies that there's just one answer, but again, I would check them all out. On this one here, and I'm so tempted to just solve it and then see which ones work, but instead, we'll go ahead and evaluate each of them. I have negative 21. It's supposed to be less than or equal to negative 4 plus 2 times whatever D is, and here D is 11. So I'm going to go ahead and just work this left side for now. Negative, or the right side, negative 4 plus 2 times 11 is 22, and negative 4 plus 22, well, I actually need to subtract 4 from 22, and that would give me 18, and the 22 has a greater absolute value than the negative 4. 22 is positive, so I'm going to leave that positive. And let's bring that to negative 21 now. Is negative 21 less than or equal to 18? Indeed it is, so this is a correct solution. And it does say select all that apply, so let's check them all out. Here I have negative 21. It should be less than or equal to, and negative 4 plus 2 times d, and d is going to be negative 8. So let's go ahead and work this out. Let's go ahead and take this negative 4, add it to 2 times 8. Negative 8 is negative 16, and negative 4 plus negative 16 is negative 20, and negative 21 is less than or equal to negative 20. Indeed, negative 21 is less than negative 20, so d equals negative 8 is good to go as well. On the next one, let's do negative 21 is less than or equal to, and it is negative 4 plus 2 times whatever d is. In this case, it's 10. Let's go ahead and work the right side. Negative 4 plus 20, and the difference between 4 and 20 is 16. 20 has the greater absolute value, and it's positive, so I'm going to leave the 16 positive. And negative 21. Negative 21, yep, it's less than or equal to 16, so this one's good to go as well. And then finally, negative 21 is less than or equal to negative 4 plus 2 times 1. Well, negative 4 plus 2 times 1 is 2. Negative 4 plus 2 is negative 2. And negative 21 there. So negative 21 is less than or equal to negative 2. And indeed, this is a true statement as well. So this one's also correct. Sometimes whenever they're all working out to be correct, I'm constantly kind of looking back and like, am I messing up someplace? But indeed, I think my math's correct all the way across there, so I'm good to go. Final question here. 1 is greater than or equal to b divided by 17. So we'll go ahead and substitute everything in. 1 is greater than or equal to, and this time the value of b is 34. So I'll substitute that 34 in, divide it by 17. Well, 34 divided by 17 is 2, correct? So 1 is greater than or equal to 2. Well, that's false. 1 is actually less than 2, so this one doesn't work. On this one here, 1 is greater than or equal to 17 over 17. Well, I know that any number over itself is equal to 1, right? So 17 over 17 is 1. So is 1 greater than or equal to 1? Indeed, 1 is equal to 1. And you can see we do have the concept of equality there. So it can be equal. So therefore, this is a solution. On the next one, we have 1 is greater than or equal to 102 over 17. Well, at this point, I should know that it's not. I mean, this is going to, like, we're talking about all numbers. If 1's greater than this, that means that whatever's on the right here has to be less than 1, correct? If 1's greater than that, then that means that this must be less than 1. So whatever we get for 102 divided by 17, it's going to be greater than 1, creating a false statement. So this would be incorrect. And then finally, 1 is greater than or equal to 85 over 17. Well, another way to think of this is both 102 over 17 and 85 over 17, both of these are improper fractions, and they're both positive, so we get a positive number. Now, if one of these were negative, we'd have to be careful. That would change things. But we do know that this is an improper fraction, and all improper fractions have a value greater than 1. So no matter what 85 divided by 17 is, it's going to be greater than 1, making this a false statement. So this is not going to be a correct answer as well. So sometimes you can use some mathematical concepts like recognizing that an improper fraction is going to have a value greater than 1. So no matter what it is, it would make a false statement. Or any number over itself is equal to 1. We might have been able to spot this 17 over 17 real quick without actually writing it out. And maybe we even realize that 34 divided by 17 is 2, and 2 is indeed greater than 1. 1's not greater than 2. So at any rate, sometimes knowing those concepts of mathematics will kind of help save us some time. And that is the conclusion of all my examples for IXL A1.K.3 Identify Solutions to Inequalities. Good luck with your activity.